Good morning. Thank you. Whoever shouted, thank you. Good morning. Good to be here. Thank you. All right, my name is Dave Thomas. I have been programming now for just over 40 years. I have programmed in more assemblers than I can think of. C, Pascal. I wrote my first object-oriented program in 1974. C++, Java, Ruby, Elixir, Erlang. I mean, basically, you know, I have done it all. And there's really not much you can tell me about programming. I know it all. I know everything there is to know about programming. You know, it's easy once you got, 40 years of experience under your belt. But the reality is, everybody gets stuck in their ways. All right? Everybody finds things that work for them, and they get comfortable. All right? This is the tools that I have. These are the techniques that I use. These are the idioms I use, the languages, whatever it might be. I get comfortable with this. And there's a synonym for comfortable, which is lazy. All right? If my way is the best way, then I don't need to find any other ways, right? Because by definition, there aren't any better ways than the ways I do things. And that's obviously not true. And the reason I'm giving this talk is because I got lazy. And I want to kind of like pass on my personal experience about how I got lazy and then falling out of laziness, how I learned a whole bunch of new stuff really, really quickly. And I got lazy because 15 years ago, just over, I wrote my first Ruby program. And I fell in love. I thought, this is the way to code. I love this language. It thinks the way I think. It's messy and it's sloppy. And there's lots of ways of doing things. It's perfect for me, absolutely perfect. And so I got really deeply into Ruby to the point where pretty much that was all I did for a long time. And I woke up every now and then and I'd go and have little forays into something else, but I'd always scurry back into the little comforting, warm Ruby hole that I was in. Until about 18 months ago, I got involved with a language called Elixir. Now, let me tell you why I got into Elixir, and then I'm going to come back and tell you a little bit about what difference that's made to me. I got into Elixir because of something called Moore's Law. Wouldn't that be cool? If that's why Moore's Law was Moore's Law. Moore's Law is basically, I'll kill something if I can make a joke about it. Yeah? But no, actually Moore's Law, most people get Moore's Law wrong. I actually went and looked it up. It's nothing to do with speed. It's to do with simply the number of gates. The number of gates on a wafer of silicon, the number of gates that can be most economically put on a wafer of silicon doubles every, and then there's some debate about the unit of time, but let's say 2 years. And in fact, that has held true. People keep saying, oh, Moore's Law is dying. It's not. No. Moore's Law is going to keep going for a fair while. I mean, look at this graph. This is a log axis on the side there. So it has been doubling since, what's that, 1970-something? 1971. It's been doubling ever since. This laptop, this little MacBook Air that weighs about 4.5 ounces, has got almost 1 billion transistors on its CPU. Probably 2 or 3 billion in the GPU. 1 billion transistors? I mean, maybe I am an old fart, but my God, that seems like an awful lot. And I know damn well that there's no way that I could write a program that could keep all those transistors busy if I wrote it in the old-fashioned way. So it became obvious very quickly that the future is functional and the future is concurrent. Okay, and you've all heard this, and I'm not going to go into this anymore at all in this talk. I just wanted to say this is why I got into Elixir. Because previously I got into Erlang, and Erlang never quite felt right to me. It was a pretty language, and it reminded me of my old Prolog days, but it wasn't really the kind of language I wanted to get associated with. And Elixir had a whole bunch of new stuff, but it still ran on the Erlang virtual machine. I got the best of both worlds. I got a kick-ass virtual machine that was designed for parallelism, designed for concurrency, designed for distribution, and I got a language that felt like Ruby, So there I am back in my old rut. But what I discovered was that as I learned Ruby, I started learning a new vocabulary and a new way of thinking. And that's what I want to pass on today. The idea that the language that you use, not just the programming language, but the language you use to describe things, affects the way you think. Now, this is actually relatively controversial in kind of scientific circles. So at this point, I have to make my token appeal to authority, right? Because I have to sort of like buttress what I'm about to say by choosing some weird people you may not have heard of. So first guy I'm going to call on here is Ludwig Wittgenstein, philosopher. He actually, here is pictured just after he failed the screen test for Eraserhead. So, and he actually is relatively famous for writing just one thing. He wrote one paper, Logicus Tracticus Philosophicus, you can read it, right? Two cool things about this paper. The first is the introduction. In the introduction to this paper, I'm actually going to read it. How far my efforts agree with those of other philosophers, I will not decide. Indeed, what I have written here makes no claim to novelty in point of detail, and therefore I give no sources, because it is indifferent to me whether what I have thought has already been thought before by another. This guy is a programmer. But the one I want to talk about here is this quote. The limits of my language are the limits of my world. And what he actually says about this is the only reality that exists is the reality that you can describe. If you don't have words for it, it doesn't exist. It's not that it doesn't, it's there, but you can't describe it. It doesn't exist, is what he says. You can agree or disagree. There's actually a really trivial kind of, quote, proof of this, which is you say, well, that's ridiculous. So I say, okay, tell me something that exists that I can't describe. Anyway, language changes the way you think. And that's what I want to talk about today. Next slide of someone that you don't recognize. In the old days of talking, you used to put up Guy Steele and people like that and say, who recognizes this? And there'd be, well, it's Guy Steele. All right, now it gets too easy to do those people, so you have to do obscure people. This guy is Benjamin Whorf. Benjamin Whorf was an American linguist. He was also a pretty kick-ass fire prevention engineer. But we won't talk about that part of his career today. And he came up with this concept that he called linguistic relativity. The only reason it's called linguistic relativity is that relativity was a kind of hot concept, thanks to Einstein, back when he came up with this. And he thought, hey, if I call this relativity, then everyone will go and read it because it's really, really cool. But he came up with the idea of linguistic relativity, which we now call the Sapir-Whorf hypothesis, which is interesting because they never actually work together, and there is no such thing as the Sapir-Whorf hypothesis. Anyway, the Sapir-Whorf hypothesis says that what you think is dictated by the language you use to think about it. So language is a filter through which we see the world. And in line with Wittgenstein, they say if we don't have words for something, it's hard to reason about it. And that kind of seems to make sense. Now, during the 60s, this fell out of favor because it was seen to be a little bit kind of like colonialist or something, right? People who got better vocabularies can think better. And clearly this isn't right. So without proof either way, the theory fell out of favor. It's coming back into favor now, though, because people are discovering actually it's true. This is a graph of savings rates among OECD countries, all right? So the higher the bar, the higher the saving rate. The color of the bar, the shading of the bar, is an indication of how many ways there are of expressing future tense in the national language of each country. So if it is a dark bar, then we have lots of ways of expressing future tense. If it's a light bar, we only have a few. And what do they find? Strong statistical significance that countries that have more ways of expressing future tense save less, which you might think is kind of the wrong way around. But the theory is, and they're still trying to prove this, the theory is that the more ways you have of being able to express the future, the easier it is to rationalize it away, and you don't worry about it as much. That's the theory. One more, and I'm sure you've all seen this at school, right? The world-famous Stroop Effect, which is still being argued over, I don't know, 40 years later. They're not 100% sure exactly what's going on. But in the Stroop Effect, you have words and you have colors. And what you have to do is ignore the word and just call out what color it is. So on this first line here, you would want to say green, red, blue, orange, yellow. How hard can that be? So, audience participation time. We'll take this first one slowly, okay? So, I'll just go like tap and call out what you see there, okay? So remember, you're calling out the color and not the word. So I'll give you a hint. We're all gonna say red for the first one, okay? Ready? Here we go. Oh, perfect, 100%. Well done. Okay, let's just bring up the pace just a little bit, all right? Here we go. Blue, green, white, red, orange. Kind of falls apart, doesn't it? So clearly, there's some really, really deep thing going on in your head to do with language. Right? Language isn't just the way you express your thoughts. Language interacts with your thoughts. It interacts with your vision. It interacts with almost everything you do. It's primal in what you do. So it would seem to be a good idea to be conscious of that. Be conscious of the fact that the limits of language are the limits of your world, and try to expand the limits of your language. If you've only got 5 words for concurrency, maybe you need to have 11, just like colors, you know? So what I want to do is to talk about my personal experience. This is going to be different for everybody here, but I want to talk about my personal experience and what learning Elixir has done to the way I think about programming now. Now, I would really, really like to talk to you for like about 3 hours about Elixir and coding and everything else. And I learned just before I got on that I don't have even an hour for this. I'm supposed to have 45 minutes. So this is going to get a bit tight. So let me talk about some of the things in Elixir that have changed the way I think. And the first one is transformation. So let's imagine that you had to write a program that would find anagrams, right? Words that have the same letters but in different orders. And one thing you might decide to do is to look for the signatures of words such that if 2 words are anagrams, they have the same signature. And one way of doing that is to take your word, split it into characters, and sort those characters. Because then, if you were to do that for, say, the word listen, you get the signature E-I-L-N-S-T. If you do it for the word silent, you get exactly the same signature. So therefore, because of that, the 2 are anagrams. Yeah? So there's a simple bit of Ruby code that calculates the signature of a word. And I know Ruby programmers in here would probably say, oh, you want to use pack and unpack because that's going to be about 8 microseconds faster, and I know, but whatever. So here's our signature in Ruby. Here it is in the equivalent Elixir. And that's pretty much how I would have written Elixir a year ago. Yeah? Some of the function, because it's a functional language and not an object-oriented language, you have function argument, not argument dot method. But other than that, you can pretty much read that. So toChar list takes a string and converts it into a list of characters, and then fromChar list takes a list of characters and converts it back into a string. Otherwise, it's pretty straightforward, right? Now, if we look at just those 3 lines of code in the middle there, you can say, well, that's a little bit ugly because we have all these temporary variables and everything else. So can we tidy that up a little bit? And yeah, of course we can tidy it up. And we can tidy it up in the kind of way that we all see all the time in code everywhere. All right? I want to avoid typing variable name equals. So what am I going to do? Oh, I'm just going to mix it all together like that and nest. So I'm going to have my word gets converted to a character list, going to get sorted, and then gets converted back from a character list. And when you're writing it, it makes perfect sense. But remember what Brian said, is that we don't code programs to write them, we code them so we can read them. All right? So if I gave you that just blind, and we hadn't walked up to it step by step, and I said, hey, what does this do? You could probably work it out. It's not long. It's only 3 nested calls. But it would take you a little while. It would take you a while because you have to break the habit of a lifetime. The habit of a lifetime is to read left to right. That's what we all do. And I'm asking you to read inside out. You have to start not at the right-hand end, but like 3 or 4 characters in, actually more than that, 8 or 9 characters in with word, and then parse backwards and forward. It's really ugly. This, I think, is a kind of form of Stroop Effect. All right? This kind of reading of code gets in your way. In Elixir, though, we would write this differently. We'd write it like that. And we'd write it using this thing called the pipeline operator, which is the vertical bar with a little angle bracket next to it. And I could actually write it like this, because I can go on multiple lines. And if I write it like that, that's easy to read, isn't it? You can see what that's doing. I'm going to take a word, convert it to a character list, sort it, and then convert it back again. Step by step, top to bottom, left to right, just the way we read. And for me, that's infinitely easier to read. To express how that actually, or to say how it actually works, the pipeline operator is really, really trivial. All it is a little rewrite of the code. Whenever you see something on the left-hand side, a pipeline, and then something on the right-hand side, all that happens is that Elixir automatically puts the value of whatever is on the left as the first argument to the function on the right. That's all there is to it. But by doing that, you get that ability to pipe things together. So here's our anagram signature code as a pipeline. And you think, okay, I can see for trivial little things like, one little function, I can see how that would be really useful. And that's kind of like the second stage of my progress to Elixir enlightenment, was thinking, yeah, this is a really useful technique for writing small little functions like, anagram or whatever it might be. And then I realized that, in fact, there's more to it than that. Because that pipeline operator is actually representing a transformation of data. Every time I see that pipeline, I know that I'm taking some set of data and somehow transforming it into another set of data. So for example, something as mundane as an order processing system is really a little conveyor belt that takes orders in at one end, and then it'll get, I don't know what it does, calculates the tax, generates pick lists, creates the shipments, invoices the customer, all these kind of things along a little conveyor belt. And that is transformation. And once you start thinking about programming in terms of transformation and not just in terms of managing data, suddenly you're liberated. It changes the way you think about everything. For example, there is nothing to stop this being parallel. And in fact, in Elixir, it can be parallel pretty much automatically. You don't even have to think about it. It's just a phenomenally different way of thinking. So if you think about transformation, in OO, our biggest concern is encapsulation. All right? People will tell you all about, object orientation is all about encapsulating data and protecting it using methods. You can't get to the data except through the methods, and that is how you guarantee good design. And for the longest time, I thought that was absolutely right. Now that I've been doing more functional style programming, okay, I'm realizing that in functional programming, what I worry about is transforming the data. And having an idiom that helps me do that transformation really just helps me focus on it all the time. It makes it the easiest path to take, again, to quote Brian. So in OO development, we're worried about encapsulation. In functional programming, we're worrying about transformation. So let me just kind of tease you with a simple question. Of those two things, hello, there we go, which actually generates business value? Yeah? Encapsulating data may be great for us, maybe. I'm not convinced. But I don't generate business value by hiding the data away. I generate business value by transforming that data. And realizing that really changed the way I think about programming. So I now think of programming in terms of nested and potentially parallel transformations of data. Every program I write is a pipeline. And I've written some pretty weird programs that way, and it works every time. I have a little exercise I go through whenever I'm trying to really deeply learn a language, and that is I write a markdown formatter. You know, markdown is that language which is like you write effectively plain text and it formats it up really nicely, and there's like links and headings and all this kind of stuff. It turns out markdown is a really, really ugly syntax to describe, which makes it a really hard, not hard, a very messy thing to program, which is why I like it, because it makes me exercise all sorts of different things to write a markdown interpreter. And writing a markdown interpreter in Elixir I do it the same way. It's a set of nested transformations. It's a pipeline. And it's a very, very elegant way of doing it compared to most other ways. The other thing that's really interesting to me about this is we all talk about decoupling, right? Decoupling is one of the main big design points. Everybody wants to decouple code to make it better. And yet, we tightly couple our code and our data. In functional programming, we decouple code and data. So we actually achieve an extra degree of separation. Again, something to think, what I'm trying to do here is kill all these sacred cows, so forgive me. One more thing I want to talk about is pattern matching. And this is not unique to Elixir. Most functional languages have some form of pattern matching. So if I was to write that, you'd probably say in your heads, A equals 1. Yeah? And that's reasonable. If you did, any kind of algebra in school, then you'd know A equals 1, equals, right? That means that the left-hand side equals the right-hand side. Yeah? Which means there's no reason at all why I can't write that, yeah? If I'm writing equals. But what's happened is, in modern programming, not even modern programming languages, starting in Fortran and C and whatever else, right? Equals got stolen, right? The evil people that design these programming languages says, oh, this isn't equals anymore, this is assignment, right? Take the right-hand side and force it, unwilling, into the left-hand side, right? Jam it in there. That's what equals is. But it's not. Equals means simply, algebraically, I want this to be the same as that. And Elixir says, or any functional language would say, oh, okay, I can do that first one if I say that A has the value 1. Sure, it has the same effect as assignment. Second one, though, if A already equals 1, then that's just true. And the compiler goes, I have no idea where you wrote that because it's obvious, but yeah, okay, fine. A equals 1, 1 equals A. In this case, I would not be able to write 2 equals A because it knows that A equals 1, so it would actually complain that A doesn't equal 1. And in fact, this is how we write our assertions in Elixir. Anyway, it goes deeper than that. 1, 2, 3 is a list of 3 values. Now, if I was to say A equals 1, 2, 3, then to make that true, A would become the list 1, 2, 3. But here what I've said is I'm pattern matching. So the left-hand side is also a list. And it happens to have 3 variables in it. So to make this work, the only way to make it work is for the language to set, or not to set, to associate 1 with A, 2 with B, C with 3. So the pattern match actually is going to generate those 3, if you like, assignments, although they're not. So we can deconstruct data as we pattern match it. We can take it a little bit further. If I was to use this syntax with the vertical bar here, this means separate the list into a head and a tail. So if I was to do that statement, then A would become associated with 1, and B would become associated with 2, 3. And because our data is immutable, this does not create a separate list. If you think of it in terms of pointers, then B simply points one element in to the list, just 2, 3. Very efficient. This is pattern matching. One last example. The top here is our syntax for a map, an associated array, a hash, a dictionary, whatever you want to call it. So I have 3 elements in here: name, likes, and lives in. And now I'm going to do a pattern match here, or an equals, between my person value and the pattern name is A, lives in is B. And to make that true, then what it has to do is associate A with Dave, B with Texas. Very powerful way of disassociating data, or disassembling data. Now, let's take that a step further. If you go to Wikipedia or any other tertiary source, then you'll discover that the definition of Fibonacci is this. Yeah? Fibonacci of 0 is 0, Fibonacci of 1 is 1, Fibonacci of n is Fibonacci of n minus 2, blah, 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 right? So let us, with a push of the button, convert this into runnable Elixir code. Well, that's it. Because pattern matching also applies when I invoke functions. So if I was to call fib and pass it as a parameter 0, then it's going to go through here and look to see which one of these does it match. Oh, fib0 is this top one. So it's going to invoke that function and return 0. If I call fib1, it's going to invoke this function and return 1. Cool. Right? Otherwise, it's going to call fibn, which is the third case there, and that's going to do the recursive step to generate our Fibonacci sequence. Not the most efficient way of doing it, but it works. Note there is not a single if statement in our Fibonacci program. There's not a single loop in our Fibonacci program. It's just a set of function definitions. In fact, what it is, sorry, one more thing. If I actually want to make it correct, Fibonacci is only valid for positive numbers or non-negative numbers. So I can do this, I can add a when clause, and this has an interesting effect. If I was to say fib27, then it's going to be fine. It's going to go fib27 is the same as fib25 plus fib26, and then recursively and very inefficiently calculate the whole value. If I say fib minus 1, it's actually going to say fib is not defined for minus 1. Right? There is no function that matches fib of minus 1. It's not that I tried to call fib and it said no. It's saying, no, there is no function that does that, which is wonderful. Another example. I want to find the length of a list. So again, I use pattern matching. The length of an empty list, so here I'm saying length, and the pattern I'm matching is a square brackets, right? An empty list. The length of an empty list is 0. The length of a list, any other list, well, any other list will consist, remember that notation with the vertical bar, of a head, which is a value, and a tail. Well, I don't care what the value is, I just care that there is one. So I'm saying here, underscore is my head, t is my tail. Well, the length of this list is 1 plus the length of the tail. And in doing this, my list goes down in length 1 for every time around this iteration, or every time around this recursion. And as eventually I hit the empty list, it returns 0, and the thing terminates. The cool thing about this is that this is not necessarily a program. In the same way that my Fibonacci code went from those 3 expressions into 3 lines of code, what I've really got here is a specification for what I want to do. And that's how I think about that kind of coding. I think of it as specifying things now. Right? Even though I know we're not supposed to think imperatively, in an object-oriented style, I do. I can't help myself. I have if statements, I have loops, I have assignments, I have all this kind of stuff that makes me think how I want to do something. Now I try really, really hard not to think about how I want to do something. Instead, I think, what do I want to get done? What transformation do I want to apply to my data? And that ends up with code like this. I will quite often write literally hundreds of lines of single-line functions. And not an if statement, not a loop, in sight. And the amazing thing is, once you get it to compile, it typically just runs. So the other thing that sort of like occurs to me, which is kind of weird, I've not seen this written before, is that once you have this idea of pattern matching and functions, what you're really doing as a transformation of your data, you're parsing data. I don't just necessarily mean text here, right? You're parsing the overall structure of data as you transform it into something else, just like a compiler parses data into something else. So let me give you an example of that. Let's say we had a real simple problem. Someone gives you a list. It doesn't have to be numbers, but let's say it's numbers. Someone gives you a list, and you have to perform some kind of run length compression on it. So the idea is, if you have two or more successive elements with the same value, I want you to replace that sequence with just the value and the count. So here, my list has 3 1s, a 2, and 2 3s. So I'm going to say I have 1 3 times, then 2, then 3 2 times. Okay? Not a big deal. Not a big deal. So just as an experiment, I coded that up in Ruby, and it worked with all the edge conditions on the 3rd try. All right? Didn't take me too long. But there was all these kind of weird things, like making sure that it handled the repetition correctly if there were only 2 elements at the end of the list that repeated themselves. That was a bit of a special case. Right? There's all sorts of weird little small things like that that kind of mess you up. Let me show how you can think about this in a language like Elixir. Okay, so we're going to have like a bit of framework. We're going to skip that for a second. So you ask yourself, okay, how do I need to do this? Well, I need to build a result list. And this is a very common pattern in functional languages, is that you will actually have your external API, in this case, compress list, and it will actually start again. I need state, and my state is my result list. Right? But I can't have instance variables. I'm not an object-oriented language. And of course, I can't have global variables. And in fact, I really can't have variables at all, because my data is immutable. So when I want to pass state around, I'm going to pass it as parameters. So I am going to invoke here an internal helper function, which I'm just calling _compress. I'm going to pass it the list I'm working on and the result, which is what I'm generating. Now, here is the first place that I think very differently. Because in my head now, I am thinking at every single point in my program, if I concatenate the list and the result, I get a valid representation of my data. Right? That is now going to become my invariant. Whatever I do, list concatenated to result will be a valid representation of my input data. It will not be the compressed form, but it will be the valid form. And clearly it's true here, because my list is the original list, and I'm concatenated to an empty list, I get my original data. So now I have to write my compress function. I'm going to show you this one simply because it appears at the top of the code. We'll come back to it in a minute. So the first case I want to think about is I just have an element at the front of my list and nothing special about it, right? So I've got the list is 1, 2, 3, and I'm looking at the 1 or the 2. There's nothing special about it. So all I want to do is to take the head of my input list and return it as the head of my result list instead. So all I'm doing in this code is moving the value from the head of the current head of the input list to the current head of the result list. Is my invariant still true? Pretty much. There's one little small twist, but it's pretty much true. All right. That's the boring case. This will process any list and basically copy it input to output. Now, the output's going to be in reverse order because I'm taking each element and sticking it as the head. So 1, 2, 3 will become first 1, then 2, 1, then 3, 2, 1. And that's why I have to do that reverse to get the right value back. And that's also a very common idiom. Okay, so this is just a list copy, nothing else. I need to be able to cope with being able to deal with duplicates in that list. And this is where it gets fun. This code deals with the case where we've just noticed a duplicate. So here I have my incoming list. Oops, sorry, wrong button. My incoming list has some element on it, and my result list has the same element. Now what is this? A is a variable. So during pattern matching, Elixir is going to say, oh, A is going to take on whatever is the current head of my input list. Later in the pattern, if it sees an A, well, it has to be that value. If my input list has 99 at the head of it, then that's only going to match if my result list also has 99 at the head of it. Yeah, those A's are both the same value. So in that case, I need to start off one of those little tuples that has the number and the count, or sorry, the value and the count. So all I have to do is to replace my A on my output list with the tuple A, 2. Pretty straightforward. And then the one other case I have to deal with is if my list has some value on it, and I've already got one of those compressed tuples for that same value on my result list. If I have that, all I have to do is increment the count. So here I'm pattern matching on A and the count, and I just replace the head of my list by incrementing the count. It took about 5 times longer to describe that than it did to actually code it. And it took me 2 goes to get it to compile cleanly, pretty much because I got the brackets in the wrong place. But then it just ran. And that is, to my mind, a very different way of thinking about coding. It's a different vocabulary, it's a different idiom. And there's interesting things about this. For example, with one minor change, I could make this so it actually worked dynamically on a stream of data. I could feed in an infinite list, or I could feed in bytes off a network and have it compress them on the way through using one of those pipelines. Yeah? The change makes the code just a little bit messier, so I wasn't going to show it to you here, but it really is very, very trivial. So, thinking in terms of transformations decouples data from the code, and that's a really big deal. And then thinking in terms of pattern matching and function invocation does something which is very much harder to describe. But what it does is it lets you decouple the what from the how. Right? I'm parsing this list looking for duplicates. You actually express that as the patterns. And then how I transform it is expressed by the bodies of the functions. And you can change the bodies, leave the function heads the same, and it still works. In fact, there was a very, once I wrote that example, I actually posted it to the Elixir list and said, okay, there are 2 ways of doing this. Remember, I was matching the head of the incoming list against the head of the result list. Another way of doing that would be to take the first 2 elements off the input list and see if they were the same. So I wrote both bits of code, and I said, you know, aesthetically, which do you prefer? And the answer was about 50-50 between the two camps. But the reality is it didn't change what I was doing. It was quite an interesting exercise that the code was fundamentally the same, just a little bit of tweak in the patterns. So why is this such a big deal? Well, for me, and like I said, this is a personal thing, right? For me, this changes the way I think about programming. And it's been a long time since I've had that experience. A lot of things, a lot of small things have kind of like gone, oh yeah, that's cool, that's cool. But to be honest with you, you come across these things, over time. Reactive programming, very cool. It's not new. It's been around probably 20, 30 years in different names, different guises. And the current implementations are way neater than anything we had in the past. Right? All of this stuff is not new. This stuff isn't new. But for me, taking it on and thinking about it and changing the way I think about coding is new. And this stuff has made me a better programmer. I still don't code just in Elixir. I code in Ruby, I code in JavaScript, I use CoffeeScript, I use all these different languages. This has changed the way I write code in all of them. This has changed the way I think about code in all of them. I now think a lot more about invariants when I'm writing my methods. The same thing about the result is the list plus the result should always be a valid representation of the data. That's an invariant. And I now consciously think about that whenever I'm coding. And I hope that as I keep doing it, I will stop thinking about it consciously and just start doing it intuitively. Because that's the aim of everything, is to make it intuitive. Now, am I saying to you all, throw down your Java, throw down your JavaScript, go write Elixir? No, of course I'm not. Because, that would be stupid. But I am saying to you that everybody here is an individual. Everybody here has their own vocabulary. Everybody has their own way of thinking about programming. But the trick I'm encouraging you to adopt here is to think beyond your current way of thinking. Try and find ways of developing a vocabulary, of learning new things, learning new techniques. And one of the ways of doing that is to take these things that you've always been a little bit nervous about and attack them, learn them. So for example, I have tried forever to get comfortable in Haskell. And there's something about it that just pushes back. I can't do it. So when Elixir came along, I could embrace many of the things of functional programming without having to dive into the full Haskell experience. And that was really cool for me. So look for opportunities to go into these scary new worlds. Our friend Ludwig, the limits of language are the limits of my world. So I think it's time that we all try to make Ludwig a little bit happier. I think it's time to deliberately go out there and experiment. Learn new languages, learn new techniques, learn new idioms. Now, you'll say to me, but my company won't let me do that. I say to you, it's not their job to let you do that. Right? We are one of the few, quote, professions that doesn't actually insist that our professionals are current. If you're a plumber, you have to take annual or biannual training. And you have to go learn the new code and everything else. You actually have to have a certificate to say, yes, I am current. If you're a lawyer, you've got to do recurring training. All of these, quote, professions, they go out and do that. Us, oh, we learned that back in college, right? What can change? Well, I mean, I hate to say it, we are probably in the fastest changing field in history. And yet, we don't take the time to go out there and train ourselves. Okay? There is a word for developers who do not spend some of their personal time keeping current, learning new things. The word is maintenance programmer. Right? If you want to do cool things, you're going to have to help yourself by taking that bit extra time to play with all these technologies. And the way things are moving, the speed that things are moving right now, today's play, next month you'll be doing it in production. So that's my recommendation. That's what I want you to come away with. All right? Build your languages by playing. And along the way, I really want you to have some fun, because that's the whole point. Thank you. Okay. have any questions? Oh, come on, I scared you all. That cannot be the case. One at the back there, I'm afraid.
Any relationship between Stroop's theorem there and Vygotsky's experience with illusions and language?
That's a new one on me. I don't know that. So I don't know.
I'm not sure this is the place to tell the story.
What I do know is they still don't 100% know why Stroop does what it does, because people try variants of Stroop and they get very inconsistent results. I do know that on the color perception one, there's an interesting secondary result that the effect is really most significant in your right field of vision. And they kind of worried about that for a little while until they realized that the language centers of your brain are on the left hemisphere up here. And so everything in the right field of vision is processed over here. And so the belief is that there's some kind of leak through between the two. But that's, you know, I don't know if anyone can say if there's a tie-in between this and this because they don't understand the underlying mechanisms.
Reduced to the irreducible, Vygotsky proved that a whole class of visual illusions, like which is the longest line, you got 3 lines that are the same and
Sure.
one's got arrows, that those are all an artifact of learning to read. And he proved it by doing his experiments on the Tartars who were illiterate.
Interesting.
And it's worth reading the story
Oh,
because it's humorous, but...
And it gives me more slides. Thank you.
Okay.
No, that's interesting. So.
Do you find that being able to think in a different way makes you write your Ruby in a way that is difficult to understand by a Rubyist who doesn't know Elixir?
That's a great question. So the question, first of all, I guess it would be comparative to what the code I wrote before, the code I write after, is it more or less understandable? The reality is that when I write my Ruby code now, the biggest differences are I write more helper methods and I write a lot shorter methods. So I will quite often write 2-line, 1-line Ruby methods as like a whole class full of methods. And I will quite often write my code where I'm passing data explicitly rather than relying on object state. Does that make my code harder to understand? It probably makes it less idiomatic Ruby. I don't think it affects it at the API level, though, so I don't think it would have any impact that way. Personally, I find the code a lot easier to work with and to change after I've written it. And I would imagine that, I mean, I've not had the experience of somebody else having to come in and play with that. I would imagine once they'd learned, like, I don't think it's even explicit, once they'd come to internalize the way I'd written the code, I think they'd find the same thing, because it really is a lot less tangled than it used to be. I mean, I used to laugh at these people that talked about getting rid of if statements, and I still think the idea of getting rid of an if statement with polymorphism, by and large, is ridiculous. I mean, it's true, it's good for big stuff, but these people that say there should never be an if statement in your code, should always, that's bullshit, right? I mean, no. The language doesn't support that, really. But I still find that the way I'm writing code now has a lot less if statements, and that does make it easier to understand. And I think most people would find it easier to understand. So my code has become more declarative, let's put it that way. Sir, just.
Oh, thank you. Okay.
Ask and you shall receive.
Thanks. It doesn't always work that way. You know, this is my first experience with Elixir. So, do you have any examples of where it's actually being used in production, or is this another quote-unquote toy language?
It's, okay, that's a good question, if very, very unfair. So there's 2 answers to that. Elixir, the language, is still being developed, as I know to my cost, because at every micro release at the moment, I had to rewrite whole chunks of the book. You would be ill-advised to use Elixir in serious production right now. It will hit 1.0 sometime in the summer, and at that point, it will stabilize to the point where your APIs will be solid, and you can think about writing it in production. The thing about Elixir, though, is that it is a language written on top of a virtual machine in the same way that Scala and Clojure are written on the JVM. It's written on top of the Erlang virtual machine. And the Erlang virtual machine has been in production longer than the JVM has. And it has some interesting characteristics. There are Erlang implementations right now that achieve 9 nines uptime, which basically means they're down for like a picosecond every century or something stupid. And they achieve that because the actual architecture is robust and scalable, but also because it has features that many languages don't have, such as hot code swap. So if I need to update my code, I can put it into a running Erlang application, and in a controlled way, it will actually manage the migration of my data into that new small component in the overall code. So for example, Erlang is used for things like telecom switches. And as they're running, they will update the code as traffic is being switched through them, and it doesn't go down. That's how they achieve that kind of uptime. So although right now I would not recommend writing production code in Elixir, I would definitely recommend learning it, simply because in, you name it, 6 months, it will become a very viable language for writing those kind of applications. Not everything. You know, I would still, if I had to write a REST service that was only handling, 1,000 requests a second or something, then I could stick with Sinatra or whatever else you're using. But if I was going to scale it up to maybe 10,000, 100,000 requests a second, yeah, I would certainly think about writing in Elixir.
So one of the things you mentioned is that now when you write Ruby code in a more sort of functional way, you end up with a lot more function calls, which is pretty natural. I was wondering if you've seen any sort of performance degradation by switching from sort of a more idiomatic style to a new style, because function calls are obviously cheap, but they're not entirely free.
Right. Yeah, to be honest, it's not something I've ever measured. Fundamentally because if I was looking for performance, I wouldn't be writing code in Ruby in the first place. So, I kind of assume that my Ruby code is going to be glacially slow, but I'm also going to assume that 90% of my time is not going to be spent in my Ruby code. It's going to be spent in the operating system, the database, the network layers, everything else. So on aggregate, the code runs fast enough. So I've never actually done that measurement. It would be an interesting one to do. I mean, particularly Ruby 2 and 2.1 are getting a lot better at optimizing function calls. And I mean, now Elixir actually eliminates a lot of function calls. It'll notice if a function is just one thing, it will actually inline it automatically. You'll actually see it, which makes the stack traces a bit more hard to read. But Ruby hasn't got that far, but it's actually getting close to it. So yeah, no, I haven't measured it. I think there would definitely be an impact, but I don't care.
Okay.
So you had one more, I think. Just hang a second. There you go.
As you were talking, it reminded me of an old paper, "Go-To Considered Harmful." I'm wondering if you've read that recently and thought about the level of discussion that raised over time and how that totally disappeared. Or put a different way, when's the last time you wrote a go-to statement?
Well, actually, that's an interesting parallel. The reason that Dijkstra wrote "Go-To Considered Harmful" was just a letter in the ACM. The reason he wrote it was that at that time, research in computing and algorithms was about provability. And the genesis of structured programming, which is the paradigm that we're all using now all the time, is that if you can control yourself or can constrain yourself to using sequential statements, if statements, and simple loops, if you have just those three things, then you can actually reason about the code. And you can reason about them using preconditions and postconditions. And that makes life kind of simple. If you've got a go-to statement, then you cannot reason about it because you don't know where you came from. And so that you cannot reason backwards from the result back to the beginning to say this program is correct. So when he wrote that paper, what he's really saying is, the second you use go-tos, I can't prove your program is correct. Therefore, it's harmful. The reality is that died anyway because no one can prove meaningful programs to be correct. I mean, some people claim they can, but they can't. However, the interesting corollary to that is that go-to is considered harmful because you never know where you came from. Yeah? Mutable data is today's go-to. And Jessica Kerr actually tweeted something as I was writing the Elixir book, which I actually included in the book, which is that with go-to considered harmful, well, go-to was considered harmful because you didn't know where you came from. And mutable data is considered harmful because you have no idea what made the change. Yeah? And so I think there's a very strong parallel there. And I think in the same way that right now you just take structured programming as being like, of course you do it that way. Right? And you forget about the fact that back in the old days we had, COBOL where you'd self-modify the end of a procedure, end of a paragraph to do a go-to. You'd forget about that. I think 10 years from now, you'll just forget about the fact there was ever mutable data. Right? That'll just be some archaic thing that people used to do in the past. And so I think it's significant that a paper like that, which was controversial at the time, just became natural. I think the same thing's going to happen on the functional programming side, honestly. And I think with that, we're out of time. So thank you very much.